Advanced Algebra, Chapter 7, Lesson 1, and we are simplifying radicals, and I want you to take a look at one type of problem, and it creates kind of a little bit of a problem, so we're going to have to come up with a way to handle it. So that's what we're going to do in this video. Notice that if we have the expression the square root of x squared, and let's say we substituted in a value of positive 5. So that would be 5 squared, we get 25, we take the square root of that, we get 5. Notice that the answer that I get, or the simplified version of substituting in 5, I get the answer is 5, is the exact same value that I substituted in. I substituted in a positive 5, and when simplifying I get a positive 5 as my answer. When I substitute a negative 5 into the same expression, however, I square the negative 5, I get 25, I take the square root of 5, and I get an answer of 5. Notice 5 is not what I substituted into the expression. I substituted in a negative 5, and yet it produced a positive 5. So this creates a little bit of a problem when we're simplifying it and we're using just variables. What if the person decides to substitute in a negative number? How will that affect my answer of the simplification problem? Well, what happens then is for any negative real number that I put in, for a, the actual answer, the root, is actually the absolute value of what I put in. So when I put in negative 5, the simplified value that I get out is the absolute value of this negative 5, not the 5 itself. And this only happens when we're dealing with an even root. Okay? So for any even index, we're going to need to use the absolute value symbol to make sure that the root is positive when x is negative. So when I put in a negative x value, I don't say, okay, the simplified version is negative 5. It's not. It's the absolute value of this value that I put in. Okay, now that may seem kind of confusing, and quite honestly, it was a little bit confusing for me. It took a little while for me to understand this when I first learned this. So let me kind of put it in forms of a rule, and maybe that will be helpful to get you going, and then you can kind of see how this works as we move forward. So here's when we use absolute value symbols. And please understand, this is the only time you'll use it. It has to meet these conditions. The first condition is this: it's only for indexes that are even. Square roots, fourth roots, sixth roots, eighth roots, etc. We never use absolute value symbols when we're doing odd roots. If we do, we'll actually be creating the wrong answer when we substitute in negative values, because when you substitute in a negative value for a cube or a odd root, fifth root, seventh root, etc., the answer to that, or the simplified version, is the negative number. It's not the positive. It's not the absolute value of that number that we put in. It is actually the negative number. So to use an absolute value with an odd index would create the wrong answer. So we're only going to use this for even index, and we're only going to use this on an odd power root, meaning that on the exponent on the value outside of the radicand is odd. It's the only time we need to use it as odd, because if the exponent is even, we're going to square that negative number, and it's going to become the positive number that we need. Okay? So the absolute value symbol is only on the odd power variable roots. Because the variables vary, we need the absolute value symbol to make sure that we get a positive root even though we're substituting in a negative value for the variable. Again, it sounds complicated. I think doing a couple of examples will help. Just remember these two things: even index and only on the odd power roots. Okay, the only time that you would use those. All right, so let's do an example. So let's take a look at these two examples. So here's our two conditions. We have to have an even index, and we have to have an odd power root. So if I look at this first example here, I have an even index. This is a square root. The root that I get when I do my simplification problem, this ends up being x cubed. Because this is an odd power, I need to use an absolute value symbol around it to indicate that this value is actually positive even though I may substitute in a negative value. Okay, so I look at those two conditions and then I make sure that I fulfill those. In the second one here, I notice that I have an even index, right? And then I look at my roots. The x is a power of 1, so I need an absolute value. Notice there is no absolute value sign around this y squared. Why not? Because the exponent is even. I only use it when the power on this number outside is an odd power. That would be the only time I use it. So we've talked about when to use the absolute value. Let's talk about when we do not have to worry about using absolute value. So we do not have to use absolute value if the instructions tell us that we can assume that all the variables are positive. Remember, the only reason we're using absolute values is because if we're substituting in negative values for the variables, I need to make sure I have a positive root as an answer. If we're assuming that all the variables are positive, then there's no reason to use an absolute value symbol because I'm not using any negative variables. So when the instructions say this, then there's no reason to use absolute value symbols. And also we talked about there's no reason to use absolute value when we have an odd index. And in fact, if I did use them, this would create, for the second case, this would create a wrong answer. And so we don't want to do that, so we will not use those in these two situations. Okay, so again, for the example here, I have an odd root here, or an odd index, therefore it doesn't matter that this is an odd power. I don't need an absolute value sign because if I substitute in a negative value for a, the key root of that is a negative answer. And if I put absolute value around that, it would not be negative, thus creating the wrong answer. Okay, I'm going to do a number of examples here at the end of the video. You can watch as many as you'd like, and hopefully this won't be too difficult for you, and when you've seen a few examples, you'll find it easy to do yourself. Okay, so we're going to do a few examples, and again, I'll do 5 or 6. You can watch as many as you need until you think you have the hang of it. We're going to simplify using absolute value signs when necessary. So we're going to simplify using the same method that we've used all the way up until or in the last lesson, and we'll continue to use it. The index here is a 2, so because it's a 2, an even power or an even index, I'll need to use absolute value symbols. So I'll do the 64, and we'll do our upside down division, or actually I know the square root of 64 is 8. All right, and because my index is 2, I divide 2 into 2, and that gives me 1. So that's simplified. Now I need to decide if I need to use absolute values. And the only time I'll use absolute value is if the power of any of these outside is odd. X to the first, that's an odd power, therefore I would need to use absolute value symbol in order to simplify it. So that's the answer. That's the simplified version. It's not too difficult. Again, once you remember the rules and just follow the rules, we'll be in good shape. Okay, number 2 over here, I have the number 80, so I'm going to do my upside down prime factoring. So we're going to get 2, 10, 2, 5, 5, and 1. The index is a 2, so any 2 I can take out as a single number. So those 2. I then have those 2, and then I have a 5 left over. So this 2 times this 2 is 4, and then I have a 5 left over. And then I divide 2 into the power of the p, so 2 into 2 is 1 time. So this is simplified. Now I need to check if I need an absolute value. The index is even, so if any of these values on the outside is odd, I'll need an absolute value. So the power of this is a 1, that's odd, so I'm going to need an absolute value symbol around the value or the variable p. Okay, I think that's kind of self-explanatory, or not self-explanatory, but let me go up here and do a couple of other ones here. Some that maybe look more challenging. So let's take a look at number 6 here. So there's a negative sign on the outside, so that stays out there. And then I have a cube root, so I'm going to do my prime factorization with 250. So this would be 125. And whoops, no, 2's not going to go in that. Got a little ahead of myself. 5, 6, 7, 8. So that's not going to go. So we're going to have to do 5. So 5 goes into here. 25, and 5 in here is 5, and 5 in here is 1. So because the index is a 3, I need any 3 numbers can come out as 1. So those come out as a 5. And then I still have a 2 left underneath. So I'm getting kind of crowded here, so I'm going to take that, erase that, because I know what I need now. So I've still got this 2. Now 3 goes into the 4 one time, and then I'm left with 1 underneath. Now I need to decide, do I need any absolute values? The index is odd, so I do not need any absolute values, so I'm finished there. Remember, we don't use them when we have an odd index. All right? Let's do a couple other examples here. Just roll up here. Let's go ahead and do this one here, and then we'll do these values down here, because these have numbers outside. I want to show you what to do with those. All right, I have a negative sign outside already, so that's going to stay outside. I have 648, so I'm going to have to do my prime factorization with that. So 2 is 324, and then 2 into that would be 162, 81, 89, so 3 goes into that, 27, 3 goes into that, 9, 3, 3, 3, 1. The index is 4, so I'm looking for 4 of the same number. So I have 4 3s, so they can come out as 1. I only have 3 2s, so they're going to have to stay underneath. I'm going to multiply them back together, so that's going to be an 8. Now I can divide 4 into this power 4. That goes 1 time, and then I don't have any remainder. So this would be 3x 4th root of 8. And now I need to decide, do I need an absolute value? The index is even, so it's possible. Any variables with an odd exponent out here are going to need an absolute value. So this is a power of 1, so that does need an absolute value. So this would be the simplified version. Okay, let's do number 12 and 14 to wrap this up so you get an idea. Actually, maybe 15 as well, but at least 12 and 14. As I look at number 12, I have a negative 5 outside, so that stays outside. That doesn't change. And now I'm going to do 128. So I'm going to prime factor 128. Okay, 32, 16, 2, 8, 4, 2, 2, 2, 2, 1. Okay, now it's a cube index, or a 3, so I need 3 of anything gets to come out. So these 3, sorry, I kind of messed that up there, but these 3 come out as a 2, and then these 3 come out as a 2, and I'm left with 1 underneath. So this 2 times this 2 both come outside, and then I'm still left with this 2 underneath. Okay, and then we can use or do the variable. So 3 goes into, well, I'm going to need some more room, as I notice here, so let me make some more room. So this is going to be the cube root of 2 still. So 3 goes into 10 3 times with 1 left over. And then 3 does not go into 1 at all. And then 3 goes into 4 1 time with 1 left over. And then I decide, do I need any absolute values? Well, because this is an odd index, I do not need any absolute values, so this is fine. I just have to multiply these numbers on the outside together, because I never leave numbers not multiplied as a simplified answer. So 2 times 2 is 4, times negative 5 is negative 20, and then I have p cubed, and then I have an r, and then I have the cube root of 2pqr. And so I have my simplified version. Okay, let's go down here and do number 15, I think, to wrap this up, and I think that'll be good. I think you'll understand everything that you need to understand from there. All right, so I still have negative 4 on the outside, so I'm going to come up here and write this, even though it's way down there. No, I'm not. Okay, so I still have negative 4. So then I'm going to go ahead and simplify this. So 320, I need to do my prime factorization. So 320, 2 is 160, 2 is 80, 2 is 40, 2 is 20, 10, 5, and 1. Okay, it's a 6th index, so I need 6 of the same number. So 1, 2, 3, 4, 5, 6. So all of these 2s, 6 2s, come out as a single 2. So that comes outside along with the 4 that's already there. And then I have the 5 that's left underneath. So I have this 5 that I have to leave underneath there because there's only one of them. Then I can do my variables. So 6 into 9 goes one time with 3 left over. 6 doesn't go into 4 even once, so those stay underneath. And 6 does not go into 4 here either, so that stays underneath. So then I have this, don't get this mixed up here. So I can go ahead and simplify this. So the negative 4 times the 2 is my negative 8. I have x outside, and then I have the 6th root of these other values that are still underneath. So x cubed, y to the 4th, z to the 4th. Now I need to determine, do I need absolute values? This is an even index, so I do need some if I have an odd power out here. This x has a power of 1, which is odd, so it's going to need an absolute value symbol. So this would be the simplified version using absolute values because I have an even index. Okay, so I hope that was helpful for you. You can continue to watch these, rewatch them if you need help. And that's going to wrap up Chapter 7, Lesson 1 for us.